when we find to find the midpoint for the first interval, do we agree that this is going to be 0.5 minus 0, or just halfway between 0 and 0.5, which is 0.25?
Yeah.
And then let's find the next midpoint. The next midpoint will be M2, which equals, okay, halfway between 0.5 and 1. Do we agree that is 0.75? And then the third midpoint, M3, that'll be halfway between 1 and 1.5. Isn't that 1.25? And then midpoint, the next midpoint, and let me call it M4. That's halfway between 1.5 and 0.2, or subtract 2 minus 1.5 to get 0.5, and then divide that by 2. All right, so that'll be, what's that, 1.7? No, what? Never mind. Yeah, don't subtract. Actually add, not so 1.5 plus 2, not subtract. We're not finding the difference. We're finding the average. So that'll be 1.75. And then that'll be then finally M5, which is what's that? 2.25. And lastly, the last endpoint, let me call it M6. That'll be 2.75. All right. So the B minus A over N will be exactly the same. So that'll be, what's that? So B minus delta X. So delta X equals B minus A over N. That'll be 3 minus 0 over the number of rectangles, which in this case is 6. 3 over 6, which equals to 1/2. All right? Equals 1/2. And now, well, let's set up the midpoint formula here. So let's set up our area calculation using midpoints. And again, this will be using M6, that is 6 rectangles. That'll be B minus A over N. And then, well, we will evaluate F at M1 plus F at M2 plus F at M3 plus F at M4 plus F of M5, and lastly plus F of M6. All right, that represents the midpoints for the 6 midpoints. So the B minus A, we already got it. So M sub 6, that equals to 1/2. That's 1/2 times F of, let me substitute the values. F of 0.25 plus F of 0.75 plus F of 1.25 plus F of 1.75 plus F of 2.25, and lastly plus F of 2.75. Close parentheses and close the bracket. And again, we're going to take advantage of the fact that we store the function square root of 1 plus x cubed, and we're going to do the y, the bars, y bars, etc. Let's do it. Let's go for it. M6. Okay, now let's do. Let me clear all this madness here. So that'll be. Let me just do the quantity in parentheses. That'll be bars, y bars, function, y sub 1. Open parentheses to evaluate it at the smallest of the midpoints, which is 0.25. Close parentheses. Plus vars, y bars, function, y1. Open parentheses to evaluate it at the next midpoint, which is 0.75. Close parentheses. Then add plus, and let's go. Vars, y bars, function, y sub 1. and then open parentheses to evaluate it at the next end, at the next, no, not endpoint, at the x midpoint, which is 1.25 rather, 1.25. Close parentheses, and then plus vars, y vars rather, function, y sub 1, and open parentheses again to evaluate it. What's the next one? 1.75, right? Close parentheses and add plus again vars, y vars, function, y sub 1, and the next midpoint is in that 2.25. So open parentheses to evaluate it at 2.25, close parentheses. And let's add the last term of the midpoint. So that'll be plus vars, y vars, function, y sub 1, open parentheses to add the very last, what's that? The last midpoint, that is 2.75, close parentheses. And since we're done typing all the function values that we want to compute, we may go ahead and click enter. And that is 14.620, 62, 91, 86. I'm just going to go with 4 decimals for now. Okay, and then let me divide this by 2. Because, well, that's what the multiplication by half outside, right? So that's going to be, okay, let me write it down first. That'll be 1/2, 14.62, 91, 96. I'm just going to carry 6 decimals, but at the very end, I will just approximate it to 7.315.